Now, what we're going to do today is actually really focus on how we're going to define the graph using a matrix, adjacency matrix. Alright? So, what I would like you to do at the end of the lesson is understand how to represent a graph using adjacency matrix, and also able to draw a graph given an adjacency matrix. Looking at the graph and the adjacency matrix, you should be able to define things like bipartite graph, things like digraph and that sort of stuff. Alright? We will learn it as we go, and let's start off by looking at what is an adjacency matrix. An adjacency matrix for graph containing n vertices is a square matrix of order n times n. Alright? It is always a square matrix, an adjacency matrix. It's not going to be a matrix with different order, always n times n. Remember, row is I, column is j. The entry in row I and column j is the number of edges that are joining vertices I and j. Right? Now, important thing to take out from this slide, adjacency matrix is always a square matrix. If it has n vertices, the square matrix will be n times n. Put it in your bag, please. And row is always I, column is always j. We'll go through that in a few minutes. Very carefully think about, show you how to construct an adjacency matrix. By the way, I've written the test. The test will all be calc-free. There will be no calculator at all. Rory? Rory? No. Too many definitions. You have to remember the definition, not notes page. No, you don't need a notes page. Alright? Now, so the column J is the row I is from. So we are looking from A to A. In this case, there is no edges joining A to A, which means there's no loop. Correct? Because A, the only way to join A is a loop. Right? So we've got an edge from A to B. A to C, there's nothing. A to D, there's nothing. Alright? So this is what you look at. I will explain it step by step now. How we're going to draw a graph from there. Alright? So here, you need to know what a leading diagonal is. Alright? The leading diagonal is the diagonal from the very top left down to the bottom right. Alright?
Yeah.
That is your...
It's really loud.
Why are both of you late?
Sorry, we're walking down from ancient history. Sorry, sir.
It's 10 minutes late, that's not on. Because it is a square matrix, it has leading diagonal. Now, let's think about adjacency matrix from an undirected graph. The entry in row I, column J, is the number of edges that are joining vertex I to J. So from there, you can see that from A to B, there's one edge. Correct? You can connect from A to B, undirected. The adjacency matrix A will be symmetrically across the leading diagonal, where Aij equals to Aji. So you can see that this is symmetrical to that. You've got A connecting to B, one edge, B connecting back to A, one edge. Alright? From B to A is 1, from A to B is 1. Alright? Here, 2 and from and to. So it's symmetrical. This is for undirected graph. a loop is counted as one edge in this case. So A joining A is one edge, one loop. If the graph has no loops, all the values of the leading diagonal will be 0. So go back to what I've shown you just now. The leading diagonal is 0. So A cannot connect to A, B cannot connect to B, C cannot connect to C, and D cannot connect to D. So that means that there is no loop, no connection to itself. The sum of the row or columns entries give the degrees of the vertex corresponding to the row or columns, all right? So that is the sum of the row is the degree corresponding to the row or the column. If there are no multiple edges, all entry in the matrix are either 0 or 1. You can see that in that case, D to C, there are 2 edges, all right? So you can see the degree going into D is 3. You've got 3 edges. B to D and C to D twice. So if I want to draw that, this is the way I would draw it. A, B, C, and D. So A to A, there is no loop. So A is not connected to A, B is not connected to B, C is not connected to C. So A to B, there is one, I'll talk about the leading diagonal all 0 because there is no loop. All right? And it's always symmetrical about the leading diagonal. Why? Why is it symmetrical?
Undirected.
Sorry?
It's undirected.
Undirected. You go there and you can go back. The same road. It's undirected. So it's always symmetrical because it's undirected. All right? It's an undirected graph. Now, from there, you could draw something like this. It could be something different that you drew. All right? The B could be just underneath A and D and B swap places. That's fine. It really doesn't matter how you draw it, as long as you represent it carefully. All right? Next bit. Here, you can see that there's actually the leading diagonal. Oh, I didn't draw that. The leading diagonal is all 0. Again, it's symmetrical about the leading diagonal, which is this, correct? It's all symmetrical. Now, look at row 1. Vertex A is all 0. Why? It's not connected to anything at all, is it?
Yeah.
Is it connected to B, D, and C? No. So it's an isolated vertex. So if you've got one column which is completely 0, or one row which is completely 0, that vertex is an isolated vertex. All right? So this is pretty clear. A is not connected to B, A is not connected to C, A is not connected to D. All right? A is not connected to A by itself because there's no loop. Agree? It's a not connected graph. It's a disconnected graph. Here, you can see that I've got 1 at A. The leading diagonal, not all zeros. Again, it's still all symmetrical because it's undirected graph. Row 1, A to A equals 1. All right? So therefore, you can see that if anything in the leading diagonal, if there's a number in there, means there's a loop. It could be 1, it could be 2 loops, it could be 3 loops or whatever. But in this case, I'm showing you 1 loop. Undirected graph, disconnected, and there's a loop. So there are 3 things that you need to know from this graph. Now, sorry? Symmetrical because whatever you go, you'll come back. There's no direction. So symmetrical about the leading diagonal is here. Look at the leading diagonal. All right? This number, if you reflect it across, 0 is the same as 0. Yeah? 0 is the same as 0. 0, 1, 1, 0. 1 and 1, 2 and 2. Yeah? So that is what I mean by asymmetrical. Now, here, I put an arrow between C and D. Can you see the change in the adjacency matrix?
Yeah.
So here from C to D, I can go this way. I can also come this way, correct? But D to C, what happened? D to C, I can only go that way. So there is actually, with the change in number, that means that there is a direction. It is not it means that it's not symmetrical. That's not symmetrical about the leading diagonal. Alright, 2 and 1, I've circled it there. So you have got a direction from C to D in one of the edges, but the other edges is a two-way street. You can go to C, C to D, and D and back. Alright, so here again it's directed graph. This is a directed graph, not undirected. Directed graph, disconnected, and there's a loop at A. Alright? You have to identify all this combination. I can't show you everything, but I'm showing you the major one that I can think of. Now, here, can you actually write an adjacency matrix for this? What I really want you to think about is when you do. Alright, here's an example. You must always have a from, and to. Alright? Make sure that you have the from and to. Yeah, that's correct. Alright? Now, if you look at something like this, what does it tell you? First thing you look at it, is there a direction?
No.
So what if you happen to get something which is not symmetrical? You're completely wrong. Right? It has to be symmetrical. And also at D, there's something. D to D, there is a loop. Thank you. Undirected graph. So remember your from and to. Oops. I was too fast. This example, I got it from Sadler. Sadler doesn't use a from and to, but I would like all of you to put in from and to. So here, looking at this, you should know you've got, what sort of matrix is this? It's 4 by 4, is that right? You've got 4 vertices, so you've got A, B, C, D, 2. From A, B, C, D. That's how you do it. Start from there. Then you keep going. From A to A, nothing. A to B, 1 and 2. So that's 2. A to C, that's 1. A to D, nothing at all. Keep going until you finish your 4 by 4 matrix. And you can also see that, like I say, this has to be symmetrical. Symmetrical about the leading diagonal. Yep.
So wait, should we in a test write the from and the to, or is it just like assumed that it's from?
Sorry?
In the test, should we write the from
Yes,
and to?
I did say that you have to.
Sorry.
Yeah, definitely you have to write from. This is an example from Sadler. Sadler doesn't use it, but you would always do that. Some exam questions, sometimes they don't use from and to, but you should. It's always from and to. And you can see that there's actually symmetrical because there's no direction. All the edges are two ways. You can go one way and back the other way. All right? D is important to know that that's one, that's a loop. Happy with that?
Yeah.
Okay, I'll move on to the next one. Can you construct adjacency matrix for the graph below, please?
Surprisingly not that cold today. Yeah. It's because I've been farming, bro.
Now always, when you construct this, The first thing you look at is there. Is it going to be symmetrical? Is it going to be symmetrical, this one?
Yeah.
Thank you. It is. Remember your Froman too. I did have it this time. So this time it's going to be a 5 by 5 matrix. Agree? Because you have 5 vertices. Will, can you get a piece of paper out and do some work, please? Ready for me to reveal my answer? Okay, that's fine, that's fine, that's fine. I want to actually see you physically write things down. And not allergy. Thinking of allergy, please that.
Okay. And you just flip that shit. Got it.
Ready for me to reveal my answer? Is it symmetrical?
Yeah.
Yeah?
Yep.
Alright. No loops. Do things as soon as you see this graph. The adjacency matrix, the leading diagonal will always be 0. Number 1, because there's no loop. Number 2, it has to be symmetrical because there's no direction. Correct? So that's how I constructed my adjacency matrix. Now, the next thing, yes?
From A to C, how would you
A to C is 0.
E to C.
E to C.
1G.
Sorry, E to C, I don't know. It should be 1. It should be 1. It should be 1. It should be 1. It's my typing.
My
It should be
bad.
1. Absolutely, it should be 1. E to C, not 2. It's my typing. It has to be, I don't check my own work. It has to be 1. Thank you.
Oh my god.
Alright. Now, with the directed graph. Again, the entry in row I and column J is number of directed edges. Alright? A loop, in this case, the loop is counted as 1. Last year in what you learn in matrices, loop is counted as 2, but this year I just want all you to remember loop is counted as 1. Alright? So you can see that it is no longer symmetrical. Leading diagonal is still telling me whether there's a loop or not. Alright? B, there's a loop. So from A to B, that's one way. Alright? A to C, there's nothing. A to D, there's nothing. 0, 0. B to A, that's 1. B to B, that's 1. B to C, one way down. Alright? B to D, there's nothing. From C to A, nothing. C to B, one way up, 1. C to C, no loops. And C to D, this and this. Yeah, 2 directed edges. From D to A, nothing. D to B, one way. D to C, one way. D to D, no loops, 0. Pretty straightforward, hey? Yeah? Alright. Let's try this, please. Construct the adjacency matrix for the following graph. What sort of matrix should it be? What's the dimension? 4 by 4 because there are 4 vertices.
Deep saying. Has he made a lesson or has he made a mistake? Yeah. Yeah. This
Luis,
test,
Monty?
I bet you this test
Do your
will
work,
have
please.
some
Come on.
mistake, otherwise someone's going to have to correct it.
Alright, I better change my PowerPoint with that error.
Do you think he makes some banging food though? He's Malaysian, yeah. Malaysian cuisine's slaps.
Thank you for pointing out my mistake.
Yeah. No, 'cause India as well. 'Cause, yeah, Malaysia's like a melting pot. Oh, is that Singapore? That's
You can see that the leading diagonal is not all going to be 0, correct? Because there's a loop.
I don't think he does the cooking. I know, maybe.
So as
that's
soon
why I think
as
he's
there's a
so
loop,
good.
you know that leading diagonal is not going to be 0. As soon as you can see direction, arrow, it is not going to be a symmetrical graph.
Empty graph. Oh, shit, 0.
Alright, this is my first start. Always start off with doing something like this. You know that is A, B, C, D, A, B, C, D, from and to, and use the square bracket.
Taking a while.
This is
shut
my
the fuck
answer.
up.
So A to B, that's 2, A to C, that's 1, A to D,
Where
that's
did
1.
that come from?
B to A, you can't go from B to A. You can't go from B to B. You can't go from B to C. You can't go from B to D. All right? It's still a connected network. Although it seems like as if that is not connected, B is isolated, but it is not, because look at the other one. C again look as if it's isolated, but this is actually a directed graph. Alright? Directed graph, B and C, they are not isolated, but that's because that's connection. Direction from other vertices to C or to B. Got it? So undirected graph with that 0, it's not connected. It's a disconnected graph. But this is directed graph. 0 doesn't mean that it is a isolated vertex, because you could go in, you might not be able to come out. All right? So something like this sort of situation, you can think about it as a pipe network where the C and the D is where the water drains out. All right? Yeah? A to B, A to D, D to B. So there could be sort of something like A is the source of the water. So A can deliver water to B. And then there's no B cannot come back. So that's something that you can think of in that sort of situation. I'm saying that in year 12, I don't want to put the ceiling plan in, all right? Now, for directed graph, the entry in row I and column J is the number of directed edges that are joining vertex I to J. The adjacency matrix A will not be symmetrical across the leading diagonal. A loop is counted as one edge. If the graph has no loops, all the values of the leading diagonal will be 0. The sum of the row entries give the out degrees of the vertex corresponding to that row. The sum of the columns entries give the in degrees. So this is a different now. So the sum of the row, because it's from to, so it's out degrees. And then column is 2, all right? From something to, so therefore that's the in degrees. Think about the difference between out and in degrees now. All right, out degrees is from somewhere you go out, in, coming in. So here you can see that the out degree from A is 4. So from A, you can sum the row, the degrees for that, right? Whereas there's nothing coming in to A. So A is completely 0. There's no in degrees. B, from B, there's nothing going out from B, but B coming in, you've got from D, from A, from B. All right? So this is how you look at the adjacency matrix and how you interpret that. Now, can you construct a planar graph from the adjacency matrix? The word planar is very important. You must not cross. All right? So, in situation like this, the examiner is expecting you to understand what a planar graph is. He's expecting you to know how to interpret the adjacency matrix. All right? So how many vertices will there be for this one? Yep. Straight away 5. So draw the 5 points. And then A, B, C, D, E. Label it, please.
It's undirected, right?
I don't know. Is it undirected or directed?
Undirected. Right,
Why?
Symmetrical.
Symmetrical. So you look at this, straight away you know is undirected, right? So that it's symmetrical about the leading diagonal. That's the thing that you look at. That's the first thing you look at. All right? And will there be a loop?
Yep.
Where?
D to D.
Yep, straight away. So there are two things that you have to be able to decipher from that. Looking at it, 5 vertices, it's undirected, and it's also, there is a loop at T. Now again, remember the word planar. No edges can cross. Will, can you put it away, please? This is what I do first thing. Now, I started from A, that point, and just went around. It really doesn't matter where you start. Your A could be here, your B could be here, or whatever. All right? And of course, the thing that I must remember is there's a loop. So D, straight away I could draw a loop. There are 3 things that you can draw straight away. All right, the loop, and then the vertices. And label it. Make sure that you label it. All right? In the exam, they are very careful with labeling the vertices. The main reason for that is actually for ease of marking as well. Ready for me to review? Okay, all right, that's fine. I'm just going to take it easy.
You get that.
That's you must know.
No connection though.
All right?
Misread.
Do a lot of that, mate. Shut the Mr. Liz assistant. Yeah, Mr. Liz was teaching me.
Now, the other thing that you can notice, what happened at E?
Nothing.
Isolated, thank you. So undirected graph is isolated. All right? I'll review my answer now. That's it. Something like this. All right?
Why does he make it so complicated?
So, if this happens to be a 2, which means you've got 2 loops, that's all. All right? That just means that there are 2 loops. That's it, if there's happen to be 2. But in this case, we only have 1 loop.
No, it's really something.
All right, let's try the next question, please.
Oh, direct.
What's it?
Let's do it 24 minutes of teaching. That's right.
Is this directed or undirected?
Direct. But it says directed in the question.
Don't probe the teacher.
Directed or undirected?
Bro, it says directed.
Directed because.
Not symmetrical.
Thank you.
And it says directed.
Not symmetrical.
Killed. It's out of the class. A to B.
Would it have to be planar or could it just be?
Did I say planar?
No. No, you didn't.
So it really doesn't matter.
It doesn't matter.
That word is important. The word planar is important. So this is just a directed graph.
Yes,
You
but
need to
it
show the
is.
arrow. All right. I didn't say it's planar, so you don't have to worry about it being planar. Agree?
A to D.
Unless I use the word planar. I mean, if you can draw it, I think I drew it as a planar graph.
Of course you did. It just makes life a little bit complicated.
I can tell you graph theory is one of the hardest questions to mark because there's so many variations in drawing the graph. We got to really make sure that every graph that you draw are correct. So I'm gonna, yeah. So one thing that some examiners will do is actually put in the points and label it so that makes life a little bit easier. But generally, if I ask you to draw, I probably will just leave it a blank space. It depends on who the teacher is.
I want to make it nice, you know. Do that.
Can I review my graph? No.
Oh,
Okay,
bro,
you
calm
go
down,
home.
sir.
Do you enjoy taking as much time as you do actually?
Again, is there a loop?
I take pride in my work.
Thank you. There's a loop.
That's right.
A to D.
Loop down?
D to D. A to D.
So you have
All right. This is what I started doing from A to B.
A to D.
A to B, that's one direction. So I drew two lines with the arrow showing. B to C, two lines because there are two lines with two arrows. You must make sure that you must always put the arrows in. And then C to D. And then B, that's a loop, D to A, and D to B. Alright? So it should look something like this.
Did he realize
Your
the whole
graph may not
isn't
necessarily be the
directed?
same as mine.
Does he realize that? Sir?
Happy with that?
Is B to C, B to C is 2, but then C to B is 1. So wouldn't it be 1's directed and then 1's
Yep.
undirected?
So C to B directed, that's one.
Yeah, no, you did.
So B to C, that's two directed.
Right.
Yeah?
Wait,
Yeah.
what?
Wait, I thought we could turn Korean to.
Wait, B to C.
Sorry? No, you don't.
You don't need to draw the direction for one.
All right, that's a good
Surely.
question.
He
Listen,
just added
please.
in another one.
You always, if there are two edges going in, always draw two edges. Do not put two arrows in
I
there.
just did this.
All right?
Yeah, I just draw the edge like that.
No, don't do that.
Because
You
the A to
can,
D is
I
the
mean,
same as G
yeah,
to
you
H,
can,
so
but
it's one.
try not to.
There's no
All right.
arrow.
Question. You can actually, if you don't have that, you can put one in, one out. But generally, with the directed graph, I would prefer that not to happen. This is a better way of doing it. It's a lot clearer. All right? It's a lot clearer.
already two.
Yes, you can. You
wouldn't
can put
need
the
to
two
put
arrows
extra
in
one,
one.
right?
Yes.
Because the one is
But
really included in the two.
it's a lot
Put
clearer
one
this way.
in
That's all.
with an arrow.
All right. Now,
He's
this is summary of what I've taught you, the characteristics of adjacency matrices. Undirected graph is always symmetrical about the leading diagonal. Alright? Directed graph is not symmetrical about the leading diagonal. Yeah, that's one characteristic. Number two, any non-zero values in the leading diagonal will indicate the existence of a loop. So you can see very clearly that B, there's a loop. Alright? So that's number two characteristic. I think that's the third one. Yeah. Characteristic of adjacency matrix. A row consisting of all zero indicates an isolated vertex. Now, this happens if it is undirected. Alright? It could So in a directed graph, you actually do have to draw it and see what happened. Alright? So in a directed graph, you may still have something that A can go into there, and that's nothing B coming out. Alright? So it could be all zero, like what I showed you just now. So make sure that you are very careful when you look at this. If it is a directed graph, it may not necessarily be isolated vertex. Alright? You will also observe that. Alright. Now, if it is a directed graph, let's go back to my directed graph just now. I need to go back to that directed graph just now.
Why does he draw like 3 vertices?
Alright, this one. Now, if you have a look at this, although here you can see that the row is 0, alright, the column itself is not 0.
Yeah.
Alright? So therefore, there's still connection. It's just that there's in and out degrees.
Yeah.
Yeah?
Yeah.
Unless if there's nothing there, if there's nothing connected to B, if this is 0 and 0, which means these two are not there, that's isolated. Alright? Have a look, directed graph, have a look at the rows and the columns. Yeah? That will tell you. Everything will be 0. The in and out degrees for that will be 0. Alright? Whereas for the undirected, you can just look at 1. Alright, that's all I have for you today. There should be plenty of exercises in Google Classroom for all of you to do.